Alright, so good night to each and everyone. Welcome to Moyo Math past paper preparation sessions. This is day 3, and today what we want to do is to focus on 3 important topics. We want to look at transformations, quadratic equations, linear programming. So we look at a few questions in relation to those to ensure that we can answer those questions comfortably. You see these questions more so in the latter part of the paper. So from question 8, between 7 and 10, you see questions on quadratic equations, linear programming, transformations. Transformations you sometimes see as part of the last question, matrices, vectors, transformations, or sometimes you may see a transformations question in the early part of the paper. So we want to ensure if we see a question involving transformations, we can answer that comfortably. Likewise, questions in relation to quadratic equations and linear programming. Alright, so let's get started. Don't forget to spread the word. Tell your friends, tell your family, tell everyone about these sessions that are taking place to help you to prepare for that exam, to work towards achieving a distinction in mathematics. Don't forget to like, share, and subscribe to my channel. And yeah, let's get into it. So, starting off with transformations, okay? And we want to understand when it comes to transformations, understanding when we talk about transformations, what we mean. It means simply transforming or moving some figure, some shape from one position to another. So transforming a figure from one position to another position. We saw the movie Transformers. Our Transformers, we saw where a robot went to a car and vice versa, from a car back to the robot. So with transformations, we're looking at taking shapes and moving from one position to another by different forms of transformations. And the forms of transformations we need to be familiar with are, you have translation, you have reflection, you have rotation, you have enlargements, and you have as well glide reflection. Alright? So we'll be looking at 1 or 2 examples in relation to each form of transformations. So understanding with your transformations and each form of transformations that there are matrices connected to them. So when it comes to translation, we have this 2x1 matrix, and last night I would have done matrices, and we know that this is a 2x1 matrix, otherwise called a column vector. And for translation, we call it a translation vector. Alright, and that translation vector will help us to move some figure from one position to another by carrying out what we did last night with regards to vectors, by looking at the horizontal movement and vertical movement. So we know when we move to the right of the starting position of the particular point, it's always positive if it's horizontal. If we move to the right, if this is my point, I move to the right, it's positive. I move to the left, it's negative. I move upwards, it's positive, which represents y. Moving upwards will be y, that's positive. Moving downwards, it's negative. So for reflection, in order for reflection to occur, we need what we call mirror lines or axes of reflection. So for reflection, we need to know these important axes of reflection. Reflection in the x-axis, and for each axis of reflection, we're going to look at, not all of them, but what we're going to look at, the first 4 we're going to look at, we'll have some 2x2 matrices linked to them. And we have to know these 2x2 matrices because recently, you saw where they brought questions in relation to these 2x2 matrices. So please make sure you know them. So for reflection in the y-axis, the 2x2 matrix, it's 1, 0, 0, negative 1. Reflection in the x-axis, sorry, it's 1, 0, 0, negative 1. Reflection in the y-axis, it's negative 1, 0, 0, 1. Reflection in the line y equal to x is 0, 1, 1, 0. You have reflection in the line y equal to minus x is 0, negative 1, 0. You have reflection in the line x equal to A and reflection in the line y equal to B. So these 6 very important axes of reflection, you want to be familiar with, and you want to be able to as well answer questions where those axes of reflection will come into play. Now, of course, for reflection or for each form of transformations, there are equations linked to them. So let me just go back to translations. For your translation, the equation tells you to move from object points to image points. So note that there's a formula to help you to move from object to image points and vice versa. So for translation, it's object points plus the translation, which is that column vector, translation vector, and that will give us our image. So that is your translation formula you need to know. For reflection, the formula will be your 2 by 2 matrix. It's always a 2 by 2 matrix that you're going to multiply by the object points to give you your image points. Alright, so that's the formula for reflection. When it comes to rotation, note for rotation to occur, you need a center of rotation. You need as well an angle of rotation. Normally you see 90, 180, 270. Those are the angles they use: 90 degrees, 180 degrees, 270 degrees. And the direction of rotation. So the rotation, the direction can be anti-clockwise or it can be clockwise. So those are the 2 directions. And these 2 by 2 matrices that are linked to our rotation and direction of rotation, those 2 by 2 matrices only occur when the center of rotation is the origin. Alright, so when the center of rotation is the origin, then, because remember you need a center of rotation in order to rotate. It's like a compass. You have your pivot. So you have 2 arms. One arm will be the pivot. You have that point stick to the paper, and then the other arm will, you'll construct arcs of that will be moving in various directions. Alright, so you need a center of rotation, and you also need your direction of rotation. Like I said, anti-clockwise or clockwise, and you have the angles of rotation: 90, 180, and 270. So for an anti-clockwise rotation, center is the origin. We have to make sure we know this 2 by 2 matrix: 0, negative, 1, 1, 0. For 180 degrees anti-clockwise rotation, you know negative 1, 0, 0, negative 1. For 270 degree anti-clockwise rotation, of course, all whose center is the origin, is 0, 1, negative 1, 0. So we have to know those 2 by 2 matrices because they're going to test you on it. Yeah? For your clockwise rotation, again, there's a 90 degree clockwise rotation whose center is the origin, and again, we have to know the 2 by 2 matrix linked to that: 0, 1, negative 1, 0. For 180 degree clockwise rotation whose center is the origin, the 2 by 2. For 180, it doesn't change. For clockwise and anti-clockwise, they're both the same. It's negative 1, 0, 0, negative 1. And your 270 degree clockwise rotation is 0, negative 1, 1, 0. But if you look at this, note the 270 degree clockwise rotation. So you have, so 270 degrees will be this, and this is moving clockwise. So a 270 degree clockwise rotation, if you look at the 2 by 2, is the same as a 90 degree anti-clockwise rotation. Alright, so that is important to know as well. So a 270 degree clockwise rotation is the same as a 90 degree anti-clockwise rotation. Yeah? And also a 90 degree clockwise, if you look at the 2 by 2s, is the same as a 270 degree anti-clockwise rotation. So these 2 by 2 matrices are important to know. So please make sure you know these 2 by 2 matrices before you enter the exam, right? So for reflection, 4 important 2 by 2 matrices: reflection in the x-axis, y-axis, the line y equal to x, the line y equal to minus x. So there are 4 very important 2 by 2 matrices. And for rotation, there are 6 2 by 2 matrices you need to know. Note, there's the anti-clockwise rotation, and the angles used are 90, 180, 270. Of course, all occurring about the origin. And you have the 2 by 2 for 90, 2 by 2 for 180, 2 by 2 for 270, right? So that is anti-clockwise. And for clockwise, you have 3 2 by 2 matrices. You need to know again, all whose center is the origin. So we have a 90-degree clockwise, 180 clockwise, 270 clockwise. So 6 2 by 2 matrices you need to know for rotation. And the formula for rotation is to move from object to image points will be your 2 by 2 matrix multiplied by the object points to give us the image points. And we can look at 1 or 2 examples where the formula will come into play to help us to find what is required. Yeah? Of course, for an enlargement, you need, again, a center of enlargement. So you need that center of enlargement, that pivot, and you also need a scale factor. So the scale factor will identify, by how much our object will be enlarged by, right? And enlargement doesn't only mean getting bigger, it can also get smaller, right? It can stay erect just like the object, or it can be inverted, yeah? So enlargement doesn't always mean getting bigger. It can get smaller, it can be on the same side as the object, about the center of enlargement, or it can be on the opposite side of the center of enlargement, but it can be inverted. So once it's on the opposite side, we often see of the center of enlargement, you will see where the image is always inverted compared to the object. Alright? So there's some things we need to know in moving forward. So of course, the 2 by 2 matrix for an enlargement, it's K00. K in that 2 by 2 matrix represents the scale factor. And you have to know how to find the scale factor. So I think we'll see 1 or 2 questions where that occurs. Is the image length all over the object length. So you take the length of the image and you put it all over the length of the object. And that will help you to identify what's the scale factor. And the scale factor will always indicate, how big the image will look in relation to the object, whether it's on the same side of the center of enlargement as the object, whether it's on the opposite side, whether it's inverted, whether it's erect. So the scale factor says a lot. And the formula for an enlargement, it is the 2 by 2 matrix. This is how you can use it to move from object points to image points. 2 by 2 matrix multiplied by the object points to give you your image points. And you have the last form of transformation, which is a combination of 2 forms of transformations, translation and reflection. So a glide reflection is a translation followed by a reflection, or vice versa. A reflection followed by a translation. So a glide reflection is a combination of those 2 forms of transformations. Alright? So all you want to do is to look at some questions involving transformations to see how we can apply some of what I just spoke about. Alright? Alright, so we have this question here. It says here the diagram below shows a triangle PQR and its image P prime, Q prime, R prime. So the object will be PQR and the image, it's normally denoted by P with a little stroke on top. P, like I say P prime, Q prime, R prime. Alright, so this is your object and this is the image. Now, they want us to state the coordinates of P and Q. So, what are the coordinates of P and Q? So, the coordinates of P and Q will be, if we look carefully, let me just check. Yes, these are all CSEC questions. Yes, these are CSEC questions. So all these questions here are from the CXC past papers. Yeah? So let's make sure we understand them and we understand it well. Alright? So all these questions we're going to be looking at are from the CSET past papers, and they can often, or they will often, as you look at the history of the papers, repeat the same concept in many of the questions. Alright? Not the exact questions at all times, but the same concept. So they want us to state the coordinates of P and Q. So this is easy. So part 1. So the coordinates of P, we know will be what? This is 2 on the X, and that will be 1 on the Y. So the coordinates of P will be 2, 1. And the coordinates of Q, if we look, that will be 4 on the X, and that will be 3 on the Y. So the coordinates of Q will be 4, 3. So we always start up with X, then Y, right? Then they ask us to describe fully the transformation that maps triangle PQR onto triangle P prime, Q prime, R prime. Alright? So we looked at previously, and if we look at this diagram, this here, reflection, when we talk about the different forms, they wanted to describe the form of transformation. If you look, this is your object, this is your image. The image is a what? It is a flip of the object, yeah? About the x-axis. So normally with reflection, you will see where the image is a flip of the object on the opposite side of your axis of reflection. So when we look at that clearly, the axis of reflection we're going to be looking at here. Remember we looked at the different axes of reflection, or mirror lines. So the axis of reflection we're going to be looking at here is reflection in the x-axis. So when they ask us to describe fully the transformation that maps triangle PQR onto triangle P prime, Q prime, R prime, that simply will be reflection in the x-axis, or the x-axis is the same as, just keep this in mind because sometimes they may bring it in the exam, the x-axis is the same as, in terms of an equation, it is y equal to 0. Alright? So keep that in mind. It is a horizontal line passing through 0, the origin, and therefore the x-axis is also y equal to 0. So when they ask you to describe fully the transformation that maps, so part 2, in describing this simply will be a reflection in the x-axis, or if you want to say, it's a reflection in the line y equal to 0. Alright? So very important. So we are reflecting PQR about its mirror line, which is the x-axis, to give us P prime, Q prime, R prime. Alright? And one thing with reflection, note it's a flip, and each point, the same distance of each point of your object to the mirror line will be the same distance from the mirror line to the image point. So if you look, 1 unit from P to the mirror line will be 1 unit from the mirror line to P prime. If we look to Q, we have 1, 2, 3 units from Q to the mirror line will be 1, 2, 3 units from the mirror line to Q prime. If we do the same with R, we have 1, 2, 3 units from R to the mirror line will be 1, 2, 3 units from the mirror line to R prime. Right? So reflection, the same number of units from the object to the mirror line will be the same number of units from the mirror line to image. Now let's look at part 3. Part 3 says, write down the coordinates of the images of P and Q under the translation 3, -6. So they want us to write down the coordinates of the images of P and Q. So we're focusing on P and Q only. And let me see if this will so you may have a little anyway, let's see how it works. So we're looking at P and Q. Now when it comes to a translation, so we did it last night with vectors, when you have a column vector, we know that it is represented as xy. So x will be the horizontal movement, y is your vertical movement. So if we have to write down the images of P and Q, so we want the images of P and Q, but under a what? Translation. And a translation, remember, is a column vector 2x1 matrix. Good? So x is 3. So our translation here is 3, negative 6. So let's start with P. So if it's 3, negative 6, it means we're going to move 3 places to the right because 3 is what? Positive. So this will be 1, 2, 3. And we're going to move 6 places downward. So this will be 1, 2, 3, 4, 5. Right? Now this actually, with CXC they will give you, of course, proper graph paper, or if not, they may give you a separate paper for this diagram. And if we go in 6 places downwards, we are supposed to end up here. Good? Which will be at, if this is negative 2, this will be negative 3, negative 4. This is about negative 5. Alright? Yeah? So if it's 3, negative 6, it's going to be 3 to the right and 6 downwards. Yeah? So P will end up at, let's call this, write down the coordinates of the images of P and Q on the right. So let's call it, see now we have P prime, I'll call it P double prime. So instead of calling it P prime, because we already have P prime there, I'll call it P double prime. So the image of P, which is P double prime, under your translation, this will be, if we look, this will be, in terms of the coordinates of P double prime, this will be 5, negative 5, because this is negative 2, negative 3, negative 4, negative 5. Alright? So therefore, we move 3 to the right, 6 downwards. So P double prime, which will be the image of P under the translation 3, negative 6, will be 5, negative 5. So in terms of stating the coordinates of P double prime. Let's do the same for Q. Yeah? So if we have to identify where is the image of Q under the translation 3, negative 6, is going to be the same. This is Q here. So let's translate. So we're going to translate 3 to the right and 6 downwards. This is what? 1, 2, 3 and 6 downwards. 1, 2, 3, 4, 5, 6. So Q, this is P, and I'll call that Q double prime. Good? So that's Q double prime there. Alright? And normally with translation, the image and object, the orientation doesn't change. The only thing that changes is the what? Position. So if I connect P double prime to Q double prime, what we have? The orientation didn't change, right? PQ is same line. The only thing that changes is the what? Position. Alright? Yeah? So the same line, orientation didn't change, but the position changed. So with the translation, that is what we expect to see. Alright, so we know that Q double prime here, the coordinates of Q double prime, this is 6, so we know this will be 7, and this will connect to negative 3. So 7, negative 3. So when they ask us to write down the coordinates, so these are the coordinates of the images of P and Q under the translation 3, negative 6. Keep in mind, what is the translation? And they love to bring the translation. We know what it is, the column vector, how to solve questions in relation to the translation. Alright? So let's look at another question. So let me erase here. So another past paper question. They ask us here to write down the coordinates of n. So we want to write down the coordinates of n. Let me erase. So the coordinates of n, if we look at that shape, the coordinates of n, this is n here. Alright? So for part 1 of this question, the coordinates of n will be, starting with x first, 4, 5. So the coordinates of n will be 4, 5. Okay? And then they ask us, on the grid above, draw triangle FGH, the reflection of triangle LMN in the y-axis. Okay? In the y-axis. So they want us to reflect LMN, which is the object, right, about the y-axis, which is your mirror line, to give us this image, which is FGH. So on the grid, draw triangle FGH, which is a reflection of element in the y-axis. So the first thing, we need to recognize where is the y-axis. This is your y-axis. Good? And the y-axis can also be represented as an equation. Keep this in mind as well. The y-axis can be written as x equal to 0. Alright, so sometimes when you see x equal to 0, that's the y-axis, alright? Because it is a vertical line passing through the origin. Right? The x-axis is y equal to 0 because it is a horizontal line passing through the origin. Keep that in mind, alright? And if I want to reflect, remember reflection, keep in mind what's reflection. It is always a flip of the object on the opposite side of your mirror line. So when I reflect that triangle on the opposite side of my y-axis, which is the mirror, I should see a flip of it. Alright? And to simply do so, again, easy. We can use a 2 by 2 matrix, and I'll show you how we use a 2 by 2 matrix as well, because we did matrices last night. How we can use a 2 by 2 matrix for reflection in the y-axis to get the image of element. But we can also do it geometrically. Look at how we're going to do it geometrically. And let's start with L. Good? So L will give us F, right? Looking at the order. So we're going to count 1, 2. And the same number of units from the object to the mirror line will be the same number of units from the mirror line to image. 1, 2. That is F. Good? G corresponds to M. So let's count the number of positions from the object to the mirror line. This is 1, 2, 3. You're not counting from here. You're not saying 1. You're saying 1, 2, 3, 4. So 4 units from M to the mirror line will be 4 units from the mirror line to G. 1, 2, 3, 4. Good? So this is what? This is G. And H corresponds to N. So let's see how many units. This is what? 1, 2, 3, 4. 1, 2, 3, 4. That's N. So when I connect N, G, and F, that is what we are supposed to get. Alright? Which is a flip of the object on the opposite side of the what? Mirror line, which is the y-axis on the line x equal to 0. Good? Yeah? So we want to ensure that we are clear on how to treat with this, right? So that is part 2. So part 2, they ask us to show that, which we did. Easy 4 marks. And then they ask us, use it all. Let me also show you, because I want you to also see where, because sometimes they can bring questions where you have to identify what's a 2 by 2 matrix for that axis of reflection, and you have to multiply it by the object points to get the image. So these same coordinates of FGH, right? F is what? F is, let me show you all. F is, so part 2, F, we got F to be negative 2, 2. G, we got that to be negative 4, 2. N is negative 4, 5. So I want to show you all how you can use a 2 by 2 matrix. And when we looked at the notes on before, the 2 by 2 matrix for reflection in the y-axis is negative 1, 0, 0, 1. Good? What we're going to do is to multiply, and look at the formula for reflection. The formula for reflection is this. It is 2 by 2 matrix multiplied by the object will give image. Good? So the 2 by 2 matrix is that negative 1, 0, 0, 1. Our object will be LMN, so this will be L. And what we're going to do, the coordinates of L, it's what? 2, 2. But we're not going to write it as a row representation. We're going to write it as a column representation. So we're going to write it as 2, 2. M, the coordinates are what? 4, 2. So we're not going to write 4, 2 as a row representation. We write it as a column representation in the matrix. And N, it is what? 4, 5. Again, we write it as a column representation. And when we multiply these two matrices, we are going to get the coordinates of F, G, and H, which you'll just plot. And therefore you get your triangle. So if you don't want to do geometrically, you can use the formula to get it. So let's multiply. This will be what? This will be, let's see, we're going to get those coordinates then. Rows, and remember when you're multiplying matrices, check for compatibility. This is a 2 by 2 matrix. This here will be 2 rows and 1, 2, 3 columns, right? So 2 by 3 matrix. The two inner numbers are the same. So it means we can multiply them, and the outer numbers will tell us the end result is 2 by 3. So the end result will look like this to give it FGH, FGN. So let's multiply rows by my columns. So this is what? First row, first column. Negative 1 is linked to 2, so that's negative 1 by 2, plus 0 is linked to 2, so that's 0 by 2. That's my first row, first column dealt with. Second row, first column, 0 is linked to 2, so that's 0 by 2, plus 1 is linked to 2, so that's 1 by 2. So make sure you know how to get it by the 2 by 2 matrix. And the formula. This will be what? 2 rows by my second column now. First row, second column. Negative 1 is linked to 4. So negative 1 by 4 plus 0 is linked to 2. That's 0 by 2. Then second row by my second column. 0 is linked to 4. So that's 0 by 4. Plus 1 is linked to 2. That's 1 by 2. Yeah, and then my 2 rows by my third column, first row, third column, negative 1 is linked to 4, so that's negative 1 by 4, plus 0 is linked to 5, that's 0 by 5. Then my second row by my third column, 0 is linked to 4, so that's 0 by 4, plus 1 is linked to 5, so that's 1 by 5. Of course, I put your big brackets, and let's simplify this so we're going to get those coordinates on top there. So, negative 1 by 2 is negative 2 plus 0 by 2 is 0. 0 by 2 0 plus 2 by 1 is 2. Negative 1 by 4 is negative 4. 0 by 2 is 0. 0 by 4 is 0 plus 1 by 2 is 2. Negative 1 by 4 is negative 4 plus 0 by 5 is 0. 0 by 4 is 0 plus 1 by 5 is 5. All you want to get there? Negative 2, 2, negative 4, 2, negative 4, 5. So this here will be F. We can now write it back as a row. F will be negative 2, 2. G will be negative 4, 2. And N will be negative 4, 5. Alright? Yeah? Oh, this is H, sorry, not N. Alright, so that's H then, not N. So we will see where we got the same coordinates. I mean, it's longer, but it's always good to know how to get the image points given objects for the different forms of transformations. And if you do reflection, there are 2 by 2 matrices, you need to know which can help you to move from object to image, or you can do it geometrically. Alright? So that's part 2. Let's look at part 3. Part 3 says, using vector notation, so vector notation, describe a transformation which maps LMN onto PQR. LMN onto PQR. We want to determine what's a transformation. Now when you look at that, we clearly see that can be reflection, because students might look at this and say, hey, reflection about the x-axis. No, this is not a flip. Remember, when it comes to reflection, think about what? Flip on the opposite side. That's not taking place there. This is not a flip of this. These two are exactly the same. They are congruent. That's the word they use. They are congruent. The only thing that changes is the position from here to here. Alright? So automatically that can be reflection. It can be rotation either. It can be enlargement, because that's not bigger than that or smaller than that. So the only thing it can be is a translation. The orientation is the same. The only thing that changes is the what? Position. Alright? So what is the translation? What is the vector notation? Translation vector. Alright? And we can simply apply it here. Now if you look, so with your translation vector is always xy, right? So in this case, for this, I'll write it here, part 3. So what I want is the translation. So the translation will be which is in the form xy will be what? Let's move L and P. Moving L and P are the same, right? And if you look, there is no horizontal movement. All we have is vertical movement. So because there's no horizontal movement to move from L to P, then the x will be considered 0. But there is what? Vertical movement from L to P. And you're moving how? Downwards, right? So you know that's y. So you're moving downwards. So this is what? 1, 2, 3, 4, 5, 6. So that will be -6 because you're moving what? Downwards. Yeah? Because they asked us which maps LMN, which will be the object, to PQR, which is your image. Right? So LMN is the object, PQR is the image. So you're moving downwards. Alright? So this will be -6. And we can apply it here too. N is linked to R. So you're moving downwards. 1, 2, 3, 4, 5, 6. Good? M to Q, same thing. 1, 2, 3, 4, 5, 6. All you're moving downwards. Yeah? So no horizontal movement, that is 0. And the vertical movement moving downwards will be -6. Yeah? Right, let's look at this one here. Hope you see that diagram, those diagrams. Let me highlight it. Alright, try to highlight them. This is P. Alright, and that is Q. Right. Now we're looking at different axes of reflection that we can encounter. We saw an example reflection on the x-axis. We saw an example reflection on the y-axis. You know, so you want to encounter, you know, different examples. Now this one says, let me erase this information. So this one says, the figure labeled P undergoes a transformation such that its image is Q. Good? So they want us to describe this transformation completely. So this figure labeled P, which is this figure, undergoes a transformation such that its image is Q. So P is the object, Q is the image. Describe the transformation completely. Again, they wanted to describe. They love to bring what we just spoke about, which is the translation. If you look at P and Q, no flip there, right? P and Q are basically the same. They are the same, right? They are congruent. They didn't change, right? They didn't change in terms of their dimensions and so on. The only thing that changes is the position. Alright? And we should automatically know once we change position and the orientation doesn't change, that is a translation. Okay? So the type of transformation we're going to use here to move from P to Q is a translation. So for part 1, we know it's a translation. T. And remember your translation, it's in the form XY. Remember, X is the what? Horizontal movement, Y is the vertical movement. So let's take one point. This point is the same as this point. Good? So let's translate this point to that point. And when we translate that point to that point, to move from here to here, we have to move to the what? Right, and then downwards. Good? So how many to the right? This will be what? 1, 2. You see that? So this is 1, 2. So let's highlight the positions of the dot. The grid might be a bit dark, so I hope you all see the grid properly. And then let's move downwards. This will be what? 1, 2, 3, 4, 5, 6, 7. Alright? So we're moving 1, 2 to the right. Yeah? So it becomes positive 2. And we're moving how many downwards? This is 1, 2, 3, 4, 5, 6, 7 downwards. So that's 2, negative 7. So when they asked us to describe the transformation which maps the image, the figure labeled P undergoes a transformation such that its image is Q. Describe the transformation completely. What you're going to say is a translation T 2, negative 7. That's all. And if you take any point, take this one here. This is connected to this. And let's say we're going to get the same 2, 7. This will be what? I'm moving 1, 2, right? So 2 to the right, and I'm moving 1, 2, 3, 4, 5, 6, 7. Yeah? So I'm moving 2 to the right, 7 downwards, 2, negative 7. So any point you take, 2, negative 7 to move from object to image. Translation. Now, let's look at the next. On the answer sheet provided, draw and label the line y equal to x. So this is now taking us into another axis of reflection. So let us go back to the top. So reflection, we're looking at reflection in the line y equal to x. Good? Yeah? So they want, so you see reflection in the line y equal to x. Look at the question. On the answer she provided, which is this, draw and label the line y equal to x. You have to draw that line. Good? Now, how is the line y equal to x? So y equal to x will look like this. So very important too. The line y equal to x, right, is represented as such. It is going to be a sloping line, and it's going to be a right-hand slope. A right-hand slope is a slope going this way. It's going to be a right-hand slope passing through the origin. This is the line y equal to x. Okay? So make sure you know how to draw the line y equal to x. And the line y equal to minus x, which is the other axis of reflection you need to know, will look like this. This is my y-axis, x-axis. So the line y equal to minus x look like this. So it's going to be a sloping line passing through the origin, but this time we call it a left-hand slope, and it passes through the origin. So those two lines, those two equations, you have to be familiar with, and of course, recognize the slope of the line, right? So this here is a right-hand slope for y equal to x, and this is a left-hand slope. And why? Because y equal to x, you know, a sloping line is of the form y equal to mx plus c. Good? So if you have y equal to x, the number in front of x is the gradient, which is 1, understood. And we're going to be reviewing coordinate geometry, I believe either Saturday or Sunday. We're going to get into the earlier part of the paper, right? So the gradient is 1 and it's positive. The type of slope will be a right-hand slope. And C, the y-intercept, means it passes through what? What line? What it passes through? It passes through the origin. So therefore, you know, when you have a line of the form y equal to mx plus c is going to be sloping. Yeah? Same thing, this here, y equal to mx plus c. This is y is equal to minus x. The number in front of x is negative 1, so the gradient is negative. The number in front of x is the gradient. Once y is the subject, the number in front of x is the gradient, and therefore your slope will be a left-hand slope, and c is the origin. So this is why you're going to get y is equal to minus x, and y is equal to x. They both have the form y equal to mx plus c. One a right-hand slope, the other left-hand slope. Make sure you know that. So let's draw the line y equal to x on the grid. Now how are you going to draw the line y equal to x? This is what you're going to do. To draw the line y equal to x, and I'll erase here. So to draw that line, this is what you're going to do. So y equal to x. You're going to set up a nice simple table. You're going to take your x coordinates, y coordinates. Good? So to draw that line, take all the x coordinates you see right now on the x-axis. So when we get the corresponding y, all may not be able to fit, right? But if you were to do it on your own graph page proper, you're going to see where all will be able to fit on that graph page. So this will be, let me take all the x coordinates, negative 4. This is how you're going to draw the line. As if you see y equal to x in the exam, you have to draw that line. This is what you're going to do. Negative 4, negative 2, 0, 2, 4, 6. I'll stop up to 6. Good? And look how easy. When x is negative 4, you want to find the corresponding y coordinate. So just replace x in the equation y equal to x. Replace this x here with negative 4, and therefore y is equal to negative 4. So if you have to plot this point, negative 4, negative 4, if I have to plot that, this is negative 4 on the x and negative 4 on the y. This is my point here. That's the point, negative 4 plotted. Let's plot, let's find when x is negative 2 and I replace x with negative 2, y is negative 2. So therefore I'm going to get negative 2, let me plot that point, negative 2 on the x, negative 2 on the y. You see that? So you see how my lines start to form, eh? Then I have 0, 0, 0. Let me replace x with 0, so therefore y will be 0. That's 0, 0 here. So your line y equal to x starting to take shape. Then you have, when x is 2, y is 2, so you get 2, 2. Starting to take shape. When x is 4, replace x with 4, y is 4. 4, 4. Starting to take shape. And I'll go with 6. Instead of going all the way up to 8, 8 may not be able to fit. This will be 6 up here, right? Yeah? So when x is 6, y is 6. So let me plot 6, 6. Good? So we see our line there? So I can now take my ruler and draw my line y equal to x. Good? Let me see if I'm going to draw it for you. So of course we'll be using a ruler for this. Let me use a proper ruler. So I'm going to use my ruler and I'm going to draw the line y equal to x. Good? Which is a sloping line passing through the origin. And what kind of slope? A right hand slope. Okay? Alright? So, when they ask us on the answer sheet provided, draw and label the line y equal to x, that's a line y equal to x. How did you get it? Set up a nice little table like this. Just take all the x coordinates they have, substitute it into the function y equal to x to get your corresponding y coordinates and you plot them. Simple as it. And then they ask us now, S is the image of P under a reflection in the line y equal to x. So there's a reflection in the line y equal to x. Good? Yeah? Now, with the line y equal to x, there are two ways in which you can do it. Again, you can use the 2 by 2 matrix, which is to multiply the 2 by 2 matrix for the line y equal to x, which I showed you previously, by the object points of, by all the coordinates of P, which will be on the object points. Good? So you state all the coordinates of P, so here, 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 and here, and you multiply by the 2 by 2 matrix for reflection in the line y equal to x, which is 0, 1, 1, 0. That 2 by 2 matrix we looked at previously. But the other approach, which will be simpler, and if you're trying to save time in the exam, you can simply carry out a simple rule. So this is a rule you should know for reflection in the line y equal to x. So the rule is this. The rule for reflection in the line y equal to x. What's your rule? The rule is this. If the coordinates of the object is x, y, good, then the image will simply be to switch them, y-x. So if the object is xy, this is my object, O, then the image will be to switch them, yx. And you're going to get the coordinates of the image. Alright? Otherwise, you can use the 2 by 2 matrix and then multiply by the object points to get the image points. So for example, let's take these 4 points. This point here is, alright, 4, 2. Alright, I'll do it one by one. So starting with this point here, this is 4, 2. Alright? 4 on the x, 2 on the y. And let me Just switch them. This is what? Or interchange them. Interchange. That means we'll interchange them. 2, 4. Alright? So 2 on the x. So we plot in 2, 4 now, right? And this will be 2 on the x, 4 on the y. Right? You see, if you look, same distance from the object to the mirror line will be the same distance from the mirror line to image. Good? So that's that point. So see where already reflection taking place above that line y equal to x. Let's take the other point. Let's take, this is what? 7, 2. Let's take 7, 2. And let's interchange them. So that will be what? 2, 7. So when I plot 2, 7, the only thing is, of course, with the graph, like I said, you know, they will, CXC will give you graph paper where everything will be able to fit. So if it's 2, 7, we have to plot, then this is what is going to happen. Of course, the grid will, because you can't plot outside of the grid, eh? So you have to plot within the grid. Yeah? So this will be 2. So let me assume that is, so that will be 7 there, so this is 2, 7. Alright? So these 2 points, same distance from the object to the mirror line, will be the same distance from the mirror line to the image. Right? Let's take this point here. This point is what? 6, 4. So we take in 6, 4. So when it's a line y equal to x, if you bring one like this in the exam, y equal to x, this is how you can quickly reflect above the line, just interchanging. So this will be, if it's 6, 4, it's going to be 4, 6. Right? So let's get 4, 6. So 4, 6, 4 on the x, 6 on the y. Yeah? And then we have the last point, which is this point here. That point is 4, 4. Obviously, it will stay as 4, 4, right? So that point will move. So therefore, when I connect all my points, this is what I'm going to get. Which is a flip of that. You see, look like bat wings, yeah? So it is a flip of it. Like our bat flying, yeah? So that's a flip of it. Okay? So that will be the image of that. But again, remember, you're not to draw a graph outside of the grid. It must be within the grid. So with these questions, of course, when CXC give you their graph paper, they'll give you graph paper where everything can fit within the grid. Okay? Yeah? So of course, I would have taken this from, taken these questions from, sometimes you take it from the past papers online and so on, and you crop the suit. So, but for CXC, they will give you a proper graph page, alright? So everything will fit. So this here is the image, so this will be S. So you have P, you have S, which is the image of P under a reflection in the line y equal to x. So please make sure we know what is the reflection in the line y equal to x. Alright? Right, so let's look at this one here. Right? So looking at some examples of different forms of reflection we can encounter, right? Different axes of reflection we can encounter. So let me erase this. Right, so, let's look at this one here. They want us to describe, now looking at that, describe for the transformation that maps LMN onto L prime, M prime, N prime. This is LMN here, this is L prime, M prime, n prime. Good? And we want to describe that transformation. And when you look at that, that clearly cannot be a translation. Because for translation, again, the orientation would change. The only thing that changes is the position. If you look, this is a flip of that. Not so? It's a flip. Alright? That is not rotation either. That's not enlargement. That is a flip of it. L prime, M prime, N prime is a flip of element. Good? So, what axis of reflection are we going to use there? This will bring us back to, let's go back to reflection here. This will bring us back to, you see this reflection in a line x equal to A? That is the axis of reflection that will be applicable to this question, right? X equal to A, that mirror line will be always a vertical line. So the line x equal to A is 3. Suppose you change, put a number, x is equal to 3. So A can be any number, positive, negative. X equal to 3 will be a vertical line passing through 3 on the x-axis. That's your mirror line, x equal to 3. That's the mirror line. Good? So you want to get familiar with that mirror line. So this triangle L prime, M prime, N prime is a flip of this triangle element about the mirror line. Look at the mirror line right here. And it's clear, look at it. It's going to be this line here, this vertical line passing through 7. You see that vertical line passing through 7? And that line will be x is equal to 7. So you state the equation of the line. Good? And you can tell that is the case because the same distance from M to the mirror line is the same distance from the mirror line to M prime. The same distance from N to the mirror line, 1, 2, is the same distance from the mirror line to N prime, 1, 2. The same distance from L to the mirror line, 1, 2, 3, 4, 5, 6, is the same distance from the mirror line to L prime, 1, 2, 3, 4, 5, 6. So your mirror line there is simply x equal to 7. So when they ask you to describe fully, this will be for part 1. This will be a reflection. So it's a reflection in the line x is equal to 7. Alright? Reflection in the line x equal to 7. And then they ask on the answer sheet provided, draw a triangle L double prime, M double prime, N double prime, the image of triangle LMN after a translation. Again, they love to bring translation. By the vector 0, negative 3. Love to bring translation. Right? So for part 2, you know what's a translation? Right? X is your horizontal movement, Y vertical, but your horizontal is 0. So you know you're going to have no horizontal movement, right? Only what? A vertical movement. But how are we going to move? Downwards, right? So look at what's happening here. So if it's 0, negative 3 for part 2, this is what we're going to look at. So on the answer sheet provided, draw a triangle L double prime, M double prime, N double prime, the image of triangle LMN. So you're looking at this here. So that's the image of this triangle, alright? So let's do it. So you know with translation, the orientation stays the same. The only thing that changes is the what? Position. So I'm going to count. This is 3 downwards. 1, 2, 3. L double prime. M, I'm going to count. 3 downwards. 1, 2, 3. M double prime. N, I'm going to count. 3 downwards. 1, 2, 3. That is what? N double prime. So when I connect, this is what we're going to get. Good? Orientation didn't change, the only thing is what? Position stays the same. Translation. Alright? Yeah? And they ask, and look at it, look at what we said. Name and describe a combination of two transformations which may be used to map L double prime, M double prime, N double prime onto L prime, M prime, N prime. Name and describe a combination of two transformations. Now, when we go back to the different forms of transformations, these slides are. So, glide reflection. Glide reflection is a translation followed by a reflection, or reflection followed by a translation. That's a combination of two. So keep in mind a glide reflection. So when we go back to that question, right, name and describe a combination of two transformations which may be used to map L double prime, M double prime, N double prime onto L prime, M prime, N prime. So moving from, if you look, you want to move from here to here to here. This is a what? Translation. If you have to move from here back to here, you're going to translate. And if you have to move from here to here, you're going to what? Reflect. So you're translating to move from here to here, and you're going to reflect to move from here to there. So the combination of the two will be known as part 3, glide reflection. Alright? Okay, so let me try to see how quickly I can move, because I want to look at some quadratics and a linear programming. So let me see. Alright, quickly let's look at this one, and I'll look at. Right, let's explain a rotation, an enlargement. Right, that's how to enlarge that figure. Alright, and we'll try to move on to all. And then we need to understand this with the 2x2s as well, right? So let me see how quickly I can do those. And then we look at a quadratic. Making sure we can complete this square and so on also. This key information here, we want to make sure we understand how to solve simultaneously a linear and a non-linear. And your linear programming. Let me see how quickly we can do these things, right? So let me see how to get it done quickly. Alright, okay, so let's move on to, I'll do just another to highlight, the different axes of reflection. Let's look at this one here. So I'll do this part. Okay, so this one is, so again, all these questions are from the past papers. We're doing, different variations of questions. So when you see it in the exam, you know how to treat with it, right? So on the diagram above, draw a triangle P prime or state the coordinates of R. So the coordinates of R, this is R here. That is on the y-axis. So because it's on the y-axis, when you have a point on the y-axis, automatically the x-coordinate will be what? 0. That's automatic. And the y-coordinate will be that point at R, which is what? This is 0, 1, 2, 3. So the coordinates of R will be 0, 3. So you have stated the coordinates of R. Then on the diagram above, draw, alright, triangle P prime, Q prime, R prime, a reflection of PQR on the line y equal to 1. Good? and y equal to 1. You see, I want us to be familiar and get familiar with all the axes of reflection you can see, right? So look at this here. Reflection in the line y equal to b. Yeah, we come back to that question. Y equal to 1. What is y equal to 1? Y equal to 1 will be a horizontal line. So when you have y equal to b, replace b with any number. If it's y equal to 1, y equal to 1 will be a horizontal line passing through 1 on the y-axis. That's a line y equal to 1 there, a horizontal line passing through 1. So what I want us to do is, on the diagram above, draw a triangle P prime, Q prime, R prime, a reflection of PQR in the line y equal to 1. So the line y equal to 1 will be this. This is 1 here. That's 1 there, right? So the line y equal to 1 will be a horizontal line passing through 1, which is this line here. Right? So that's a line y equal to 1. Good? So that's a mirror line. Yeah? And what we want to do is simply reflect that in the line y equal to 1 to give us P prime, Q prime, R prime. So simple. All we're going to do is count. Let's start with R. The number of positions from the object to the mirror line. 1, 2. Is the same number of positions from the mirror line to image. 1, 2. Right? I'll call that R prime. Let's look at Q. So the same number of positions from the object to the mirror line. The same number of positions from the mirror line to image. This is what? 1, 2, 3, 4. And this is 1, 2, 3, 4. That is Q prime. And let's get P. This will be what? Same number of positions from the object to the mirror line. Number of positions from the mirror line to image. This is what? 1 and 1. That is P prime. So when we connect, that there is a reflection in the line y equal to 1. Okay? It's a flip of it. Okay? Yeah? So that is what we expect to see. And then we have the next part. Triangle P double prime, Q double prime, R double prime. A reflection of P prime, Q prime, R prime in the line x equal to 0. Good? So the line x equal to 0 will be your, hope you remember that, y-axis, right? So line x equal to 0 is the same as your y-axis, so make sure you know that. Because CXC will bring something like that, and students will be like, what is x equal to 0? That is that vertical line passing through the origin, which is the y-axis. Good? So let's simply reflect about this line. So this was, that R will stay as is, because R is on the mirror line. So that will be a R double prime. So R prime and R double prime is the same. Good? Let's look at P. This is what? P prime. This is 1, 2 from P prime to the mirror line. And this is 1, 2 from the mirror line to P double prime. Let's look at Q prime. 1, 2 from Q prime to the mirror line. And this will be 1, 2 from the mirror line to Q double prime. And when we connect, that there, see it? A flip of it. Like our back wings again, right? So that's what we're looking at there. So that is reflection in the line x equal to 0. Alright? So let me just quickly look at, alright, let me look at this one here. Okay, let's look at this one. So we look at just some examples with reflection in the x-axis, different axes of reflection you can encounter from the x-axis all the way down to examples y equal to b, x equal to a, if you have lines like that, and how to treat with it, right? So let's look at this here now. Now, the diagram below shows triangle DEF and its image D prime, E prime, F prime after a transformation. So you have DEF, you have D prime, E prime, F prime. State the coordinates of E. So the coordinates of E here will be 4, 2. Yeah? Straightforward. So E is 4, 2. Yeah, so this is 4 here, 2, right? And they want us to describe for the transformation that maps triangle DEF onto its image D prime, E prime, F prime. Now, what kind of transformation is that? So when you look at that, that clearly cannot be translation because the orientation is different. Yeah? And it cannot be reflection. It can't be reflection at all because for reflection, obviously, it will be a flip of the object. That is not a flip of D prime, E prime, F, DEF, sorry. So, the only thing that we can implement here, it can't be an enlargement. So, the only thing here is a rotation. A rotation. So, this here, this shape, DEF, when we rotate, so think about it, this rotate is going to fall into D prime, E prime, F prime. It's going to rotate. Yeah? So we have to rotate this object or that triangle DEF about a center of rotation in a specific direction for a given angle of rotation to help us to arrive at D prime, E prime, F prime. Alright? And when you look at that, if we have to rotate, then that will be okay. Check your internet connectivity. Right? I hope we all see clear enough. Oh, we having challenges seeing on you see the diagrams. All right. Let me just check something here. Okay. Okay, good. So it's good now? All right, nice. Right, so let's lower the brightness of it on the projector. All right? So what's we seeing better? Good. All right, so they want us to stay the coordinates of E, which we did. Now, they want us to describe fully the transformation that maps triangle DEF to its image D prime, E prime, F prime. Now, as I said, that can be a translation, which we can clearly see. It can be reflection, which we can clearly see. So this has to be a rotation. Take this triangle DEF, and if you rotate it, it's going to fall right into D prime, E prime, F prime. But when we're rotating, for rotation to occur, you have to explain or describe to your examiner. Rotation occurs about a center of rotation that must be included in your description. Rotation occurs in a specific direction. So the direction you have to describe that as well. The direction in this case, we're moving from DEF to D prime, E prime, F prime. That will be an anti-clockwise rotation. And the rotation here is, the rotation will be 90 degrees. Good? Now, again, when you look at that, you can recognize that this is my center of rotation, the origin. And if I move from D to D prime, the angle there will be 90. But for us to be very sure it's 90, there's a rule for the 90-degree anti-clockwise rotation that you can use to help you, or you can use a 2x2 matrix to also help it. I'll do both, so you can see it both ways, right? Where you'll take the 2x2 matrix for a 90-degree anti-clockwise rotation, you'll multiply by the object points, which will give you the image points, all right? Or you can use a rule for a 90-degree anti-clockwise rotation. So part 2, the rule for a 90-degree anti-clockwise rotation whose center is the origin. Right, this is provided the center is the origin. Then the rule is as such. It's going to be xy. So if the object points are xy, then the image will be negative yx. Alright? So let's take every point of the object. Let's take D. D is 1, 1. Yeah? So y now will become negative 1. So this is my y here. So it becomes negative 1. And x, which is 1, stays as 1. Yeah? Oh, sorry, D is 1, 2. So D is 1, 2. Sorry, 1, 2, not 1, 1. 1, 2. So if it's 1, 2, look at what's going to happen. Following the rule, this will be negative 2, 1. Yeah? And if we look, D is 1, 2, and D prime is what? Negative 2, 1. Alright? So already conforming to the rule of a 90-degree anti-clockwise rotation. Let's take E. E is what? E is 4, 2. And E prime will be what? E prime will be following the rule. So if this is positive 2, of course, this becomes, if 2 is y, then this becomes If it's negative y, that will be negative 2, and x is 4, so x, your 4 stays as it, right? So we have negative 2, 4, negative 2, 4, so e prime is that, negative 2, 4, and f, we have 1, 4, so what is f prime? F prime will be using the rule, this will be obviously negative 4, 1. And if we plot, f prime will be negative 4, 1. Alright? So, this is an important rule to know for a 90-degree anti-clockwise rotation whose center is the origin. But we can also use the 2 by 2 matrix, and I'll show you using the 2 by 2 matrix as well. When we multiply the 2 by 2 matrix for a 90-degree anti-clockwise rotation, and of course we haven't described yet, so I'll tell you what is the description when we describe it. I'm just showing you here to move from object to image, we're using a 90-degree anti-clockwise rotation, and I'm showing you we can use this rule, right? And this rule helped us to prove that D to E, D E F, sorry, to D prime, E prime, F prime, that the rule is right. Yeah? We can also show by using the 2 by 2 matrix, and let's go back to the 2 by 2. The 2 by 2, we go back to our rotation. 90-degree anti-clockwise rotation is 0, negative 1, 1, 0. So let's take that 2 by 2 matrix and let's multiply, or if you have to explain the rule, you don't have to explain the rule. You just have to simply state that this is a 90-degree anti-clockwise. So this is your description. It is a 90-degree anti-clockwise rotation whose center of rotation is the origin. So when you're describing a rotation, you're describing the center of rotation, you're describing the angle of rotation, you're describing the direction of rotation. So this is a 90, so that's what we're going to describe. I'm just showing you here that by using this rule, the rule for 90-degree anti-clockwise rotation, which helps us to move from here to here. Alright? And I'm also showing you where you can use the 2 by 2 matrix, because you can bring a question in the exam where they ask you to use the 2 by 2 matrix, multiply by the object points to get the image points. So, just ensuring that at least you're familiar with various methods you can use to move from object to image. But in your description, that's all you're going to describe. That's all. Yeah? But I'm just showing you all, just in case they tweak the question accordingly, and they may ask you to multiply the 2 by 2 by the object to get the image, you'll know what to do. So the 2 by 2 is 0, negative 1, 1, 0. Let's multiply by the object points to see if we're going to get D prime, E prime, F prime. So this will be what? D will be 1, 2. E will be 4, 2. And F will be 1, 4. Yeah? So let's quickly multiply and let's see what we're going to get. And then we move on to part 3, and I'll do another question similar to this. I'll do just look at probably an enlargement after, and then we look at cases where you have sometimes they'll bring with the 2 by 2 matrices. We look at that after, and then we jump quickly into quadratics, and we look at some linear programming. Alright, so this will be, let's do it quickly. So this is 0 by 1 is 0, plus row by column, right? First row by my first column, negative 1 by 2. Then second row by my first column, 1 by 1. 1 is linked to 1, 1 by 1. Plus 0 is linked to 2, 0 by 2. Then my 2 rows by my second column, first row, second column, 0 is linked to 4, 0 by 4. Plus negative 1 is linked to 2, negative 1 by 2. Then my second row by my second column, 1 is linked to 4. Plus 0 is linked to 2, 0 by 2. Then my 2 rows by my third column, first row, third column, 0 is linked to 1, 0 by 1. Plus negative 1 is linked to 4, negative 1 by 4. Then my second row by my third column, 1 is linked to 1, 1 by 1. Plus 0 is linked to 4, 0 by 4. When we work that out, let's see if we're going to get the coordinates of d prime, e prime, f prime, which will prove to us that it is a 90-degree anti-clockwise rotation whose center is the origin. So we're going to get what? 0 by 1 is 0, plus negative 1 by 2 is negative 2, 1 by 1 is 1, plus 0 by 2 is 0, 0 by 4 is 0, plus negative 1 by 2 is negative 2, 1 by 4 is 4, plus 0 by 2 is 0, 0 by 1 is 0, plus negative 1 by 4 is negative 4. See the importance of knowing these 2 by 2 matrices. 1 by 1 is 1, plus 0 by 4 is 0. So we're going to get a plus by a minus is a minus, 0 minus 2 is negative 2, 1 plus 0 is 1. So this will be d prime, which is what? Negative 2, 1, we'll write it back as in the row form. So this is d prime here. And then we have a plus by a minus is a minus. So we're going to get negative 2, 4, that's e prime, negative 2, 4, write it back in the row form. And this is negative 4, f prime, negative 4, 1. So you're going to get negative 4, 1, which is f prime. Alright? So it proves that this here, when you watch that and you're not sure, you know it's a rotation, you're not sure what kind of rotation. Obviously, you know it looks like a 90-degree, so you tell yourself, alright, let me see if it's really a 90-degree anti-clockwise rotation. I'm going to try the rule to see if it's that. And by trying the rule, you see where you are able to now move from the same, you're able to move from object to image. You're able to get the image points given the object using the rule. Or you're able to get the image points given the object using the 2 by 2 matrix for 90-degree anti-clockwise. And then you can state, after you're comfortable now, it is a 90-degree anti-clockwise rotation, you give a description. So now I'm going to put all this in the description. This is just to prove to yourself it's a 90-degree anti-clockwise rotation. And then you will give a description, it's a 90-degree anti-clockwise rotation whose center is the origin. Center of rotation is the origin. That's all I want for the answer. You do all this just to prove to yourself that it's done. Alright? And then we're going to state now on the grid above, draw a triangle D prime, E prime, F prime. The reflection of triangle D prime, D double prime, E double prime, F double prime. The reflection of triangle D prime, E prime, F prime in the x-axis. So we know how to do that. So on the grid above, draw a triangle D prime, E prime, F prime. The reflection of triangle, what am I saying? D double prime, E double prime, F double prime. The reflection of triangle D prime, E prime, F prime in the x-axis. So I want to reflect D prime, E prime, I'm mixing up a tongue. D prime, E prime, tie up the top, I should say. D prime, E prime, F prime. I want to reflect that about the what? X-axis to give me D double prime, E double prime, F double prime. So let me do that. So we now have to reflect about the x-axis, not so? So all we're going to do is count the positions from the object to the mirror line with the same number of positions from the mirror line to image. This is a simple case of, let me start with D prime. One position from the object to the mirror line. One position from the mirror line to image. That's D double prime. F prime to the mirror line 1, and I'm going to count 1. Yeah? So that's F double prime. And E prime, this will be what? 1, 2, 3, 4. 1, 2, 3, 4. From E prime to the mirror line to 1, 2, 3, 4. From the mirror line to E double prime. So when we connect, this is what we're going to get. And it's clear, a flip of it. Alright? So that is this question here. So let's look at another with rotation also, one similar to this. And look at a quick enlargement, and we move on to some quadratics, and then some linear programming. Alright? Alright, so let's look at this one now, right? We can give you one like this. This again is same thing, similar to the other one, except in this case, you know it's not translation, you know that. You know it's not reflection, you know that. You know it's not enlargement, you know that. Good? So this obviously has to be what? Rotation. So it states here, the diagram below shows triangle ABC. I hope you all seen it clear. And its image A prime, B prime, C prime under single transformation. Describe completely the transformation that maps ABC, this is your object, onto A prime, B prime, C prime image. We already identified it as a rotation. But let's prove to ourselves that the kind of rotation it is. When you look at that, clearly we're moving this way. Good? We're moving that way. So you want to move A, B, C, and when you rotate, you're going to land right on A prime, B prime, C prime. Okay? So this here is a what? Clockwise direction. So that's a clockwise direction. And let's prove to ourselves if it's a 90-degree clockwise rotation. Yeah? Because clearly, you know, clearly see it looks like what? 90, not so? Yeah? Whose center is the origin? So, to prove to ourselves if it's a 90-degree, again, there's a rule for a 90-degree clockwise rotation. And let's use the rule just to test, or if you want to use it 2x2, you can test. You do the 2x2 on your own just to get the practice, but I'll quickly use the rule to show that it is a 90-degree clockwise. And once you're comfortable with that, you know how to describe it. Alright? So, for a 90-degree clockwise rotation, whose center is the origin, will be what? Just get familiar with the rule. The rule is, if you have x, y as your object, good, then the rule is simply y negative x. Alright? Try to remember the rule, right? If it's x, y, then it's y negative x. So let's prove it. A, the coordinates of A, which is your object, is negative 4, 1. So this will be what? This is y. So I'm going to put this in front, and negative 4, because this becomes minus 4, right? So I'm going to put a negative sign in front of negative 4, so it becomes what? Positive 4. So A prime will be 1, 4. And let's see if that's the case. Is A prime 1, 4? This is 1, 4. A prime is 1, 4. Let's see B. B is what? B is negative 1, 1. This is negative 1 here, right? Negative 1, 1. So what is B prime? B prime will be 1. I'm going to put my negative sign in front of negative 1. So that becomes positive 1. So B prime, yes, is 1, 1. So you're proving to yourself, yes, this is a 90-degree clockwise rotation, right? And C is what? C is negative 1, 3. So what's C prime? C prime will be 3. I'm going to put a negative sign in front of negative 1, so it becomes positive 1. So C prime, yes, is 3, 1. Alright, so you have proven to yourself, you're comfortable now that it is a 90-degree clockwise rotation, because we use the rule and we've proven that, and therefore you can state as your, when you're describing, this is a 90-degree clockwise rotation whose center of rotation is the origin. Alright? Yeah? And then they ask us the translation vector T4 negative 5 maps A prime, B prime, C prime onto A double prime, B double prime, C double prime. On the diagram above, draw A double prime, B double prime, C double prime. So we want to translate A prime, B prime, C prime. We know to translate, not so? So let's translate that. This will be, so we're going with part 2. Your translation is 4, negative 5. So let's translate. So I'm going with, let me start with A. So if it's 4, negative 5, it means I'm counting the positions. So I'm counting 1, 2, 3, 4. So 4 to the right and negative 5 downwards. Right? So it's going to be 5 downwards. Right? So it's going to be 1, 2, 3, 4, 5. A double prime. Translated. Then we have, let's take B prime. So it's going to be 1, 2, 3, 4, and 5 downwards. This will be what? 1, 2, 3, 4, 5. That's B double prime. And C prime to C double prime, this will be 1, 2, 3, 4, and 1, 2, 3, 4, 5. C double prime. Okay? Yeah? Alright, and you see? Orientation doesn't change, stays the same. The only thing is the what? The only thing that changes is the position. Translation. Easy. Alright, I think I have to come back to, because I really want to start looking at the time, right? And I really want to do some quadratics. We'll see if we can do the linear programming because I'm looking at the time here. But let me do this one here, another transformation. You can see a question like this. This is an important one because I realized in looking at the past 2 years, I saw questions of this nature where the 2 by 2 matrices came into play. Alright? So let's make sure we're clear on this. So I'm erasing this. This question I think was either last year or year before. So we have the enlargement. We didn't do any enlargement, so I'll try to, before class end, I'll try to do an enlargement, right? So let's see. But this is an important one. The transformation matrix A is 0, -1, 1, 0. This is why we have to know our 2 by 2 matrices. Represents, we'll take the total, that's what it is, a 90-degree anti-clockwise rotation about the origin. Good? Because once you get those 2 by 2s, it must be about the origin. The transformation B, 0, -1, -1, 0, represents a reflection in the line with the equation y equal to -x. Good? So you have reflection in the line y equal to -x, that's a 2 by 2 linked it. Write the coordinates of P prime, the image of the point P 711, after it undergoes a rotation by 90 degrees anti-clockwise about the origin. So this is where the formula I gave you at the beginning, just scroll back up fast here. Right, so when it came to enlargement, it's always 2 by 2 multiplied by object to give image, right? When it comes to rotation, the formula is always what? 2 by 2 multiplied by object to give image. When it comes to reflection, it's always 2 by 2 multiplied by object to give image. You see, rotation, reflection, enlargement, those three will carry out the same formula, 2 by 2 matrix multiplied by object to give image. So, this question here, part 1. Write the coordinates of P prime. So P prime is the image, right? The image of the point P. P is the object whose coordinates are 711 after it undergoes a rotation by 90 degrees anti-clockwise about the origin. So all you want to do is just determine what are the coordinates of the image given the object which had undergone a 90-degree anti-clockwise rotation. So, to help you to identify what will be the image points, you use your formula. The formula is what? 2 by 2 matrix multiplied by object equal image. They gave you what's a 2 by 2. They told us what we're using, a 90-degree anti-clockwise rotation. They gave us a 2 by 2 matrix for that, which is A, 0, -1, 1, 0, times the object points. The object point is P, 711. But what we're going to do is to convert that or move it from that row format to a column format. Good? So when we multiply that 2 by 2 matrix, 0, -1, 1, 0, by P, we are going to convert P into a 2 by 1 matrix, column matrix, 7, 11. Good? And we're going to multiply those two matrices. So that is your 2 by 2 by the object, which is P, this is your P, to give us our image, which will be P prime. And this is now testing the knowledge of multiplication of matrices. So, can we multiply these two matrices? Let's check to see. if they are compatible. We did this last night, right, with matrices. This is a 2 by 2 matrix. 2 rows, 2 columns. This is a 2 by 1 matrix. They are compatible because the two inner numbers are the same. Once that happens, when we look at the orders and we see that the inner numbers are the same, it means we can multiply them. The outer numbers will tell us the end result will be a 2 by 1 matrix. So the end result will look like this, which represents P prime. How do we multiply two matrices? We take the rows of the first by the only column. So let me multiply. First row by my only column. 0 is linked to 7, so that's 0 by 7. Plus, negative 1 is linked to 11, that's negative 1 by 11. Then my second row by my only column. 1 is linked to 7, so that's 1 by 7. Plus, 0 is linked to 11, so that's 0 by 11. So we work that out, what are we going to get? 0 by 7 is 0, plus negative 1 by 11 is negative 11, 7 by 1 is 7, plus 0 by 11 is 0. So when we work that out, we're going to get P prime. P prime will be equal to a plus by a minus is a minus, 0 minus 11 is negative 11, and 7 plus 0 is 7. So this will be the coordinates of P prime, which will be the image of P which had undergone a 90-degree anti-clockwise rotation, which centers the origin, moving from object to image. Use of your formula. That's why you have to know that formula. And then part 2. Part 2 students often get confused with part 2, so make sure you understand part 2, right? T is the combined transformation. So you're combining these two transformations here, A and B. T is the combined transformation, A followed by B. Determine the elements of the matrix representing the transformation T. So T is a combination of the two matrices, 2 by 2 matrices you have up there. A, the 90-degree anti-clockwise rotation, and B, the reflection in the line y equal to minus x. T will represent the combination of the two. Now when you're combining two matrices, you combine them by multiplying them. See those 2 by 2 matrices? You combine them to get a single 2 by 2 matrix representing the combination of the two. And you combine them by multiplying, but we have to be very careful when we multiply them. So when we multiply them, this is why we have to be careful. Look at it here. So for part 2, we erase it here. When you combine them, you have part 2. We know we're going to combine by multiplying, but when they state A followed by B, most students when they read A followed by B, they know they have to multiply them, but when they read A followed by B, you're thinking this, AB. Just keep in mind for transformations, when we combine them to get a single 2 by 2 matrix representing the two matrices they gave us, and they state A followed by B, your combination is the reverse order. So the reverse order will be BA, not AB, So A followed by B will be the reverse order. You put B first, A after. That's how you want to multiply them. Alright, so students often make mistakes here, and they will put it in the order stated, A followed by B. So you do the reverse, B first, A after. So this will be B, which is 0, negative 1, 1, 0, times A, which is 0, negative 1, 1, 0. That's the order in which you're going to multiply them. Alright? So, BE. Alright? And let's multiply them to get our 2 by 2 matrix representing the combination of the two. So we're going to multiply. We're going to take the rows of the first. We know they are compatible already by the columns of the second. So let's multiply them. Let's see what we're going to get. This is what? 0 is linked to 0, first row, first column, 0 by 0, plus negative 1 is linked to 1, negative 1 by 1, first row, first column, second row, first column, now top, bottom. This is negative 1 is linked to 0, negative 1 by 0, plus 0 is linked to 1, 0 by 1. Then my two rows by my second column, first row, second column, 0 is linked to negative 1, so 0 by negative 1, plus negative 1 is linked to 0, that's negative 1 by 0. Then second row by my second column, negative 1 is linked to negative 1, so it's negative 1 by negative 1, plus 0 is linked to 0, 0 by 0. So when we simplify, what are we going to get? 0 by 0 is 0, plus negative 1 by 1 is negative 1, and I put it in brackets to separate the signs. 0 by negative 1 is 0, plus negative 1 by 0 is 0, negative 1 by 0 is 0, plus 0 by 1 is 0, negative 1 by negative 1 is 1, plus 0 by 0 is 0. So when we simplify that, what are we going to get? Plus by minus is a minus, 0 minus 1 is minus 1, 0, 0, 1. Alright? So T is the combined transformation A followed by B. Alright? And they want us to determine the elements of the matrix representing the transformation T. So that is the combination of the two. Always we take the latter, put that first, and the first goes last. Alright? And then they ask us, describe a transformation T. This is why you have to know your 2 by 2s. You have to describe that 2 by 2 matrix you just got. And when you look at that class, that is, if we go back to the top, that is this. That is a reflection. Look at it here, negative 1, 0, 0, 1, reflection in the y-axis. So they combine those two, the 2 by 2 representing a combination is that of a 2 by 2 for reflection in the y-axis. Good? So that is what you're going to describe for that part of the question. So for that part, when they ask you to describe, the description will be part 3. A reflection in the y-axis. Good? So that's all. A reflection in the y-axis. That is what this 2 by 2 represents, that geometrical. Good? Alright. So I'll take it on now in terms of transformations. Let's look at quickly. Right now we have the type of questions that you can see. Right? I'm going to start with, I want to start with question in particular, which you see completion of squares, quadratics and completion of squares, solving a linear and non-linear equation simultaneously, and sketching the quadratic function. So I want to look at this, make sure you're clear on that. You can probably look at this here as well too, where you have to fill the table, draw the graph, already have the graph drawn. I'm not sure if you've seen that. You've seen that? So you have the graph drawn, and then we have to get some information from off the graph, which I'd like to bring and ask you, right? To get information from off the graph. So we can look at these two, and then have a linear programming here. Let me see how the time is, right? Let's see how it goes. If I might just do the quadratics, and probably I'll see if I can do the linear programming tomorrow. But tomorrow I wanted to look at so statistics, probably look at the logical deduction type questions, look at functions and relations. So statistics, probably 1 or 2 logical deduction questions, functions and relations, very, very important. They bring functions every year, right? And stats, so we want to make sure we're clear on those. So let me start with this one here. Right, so don't forget, all viewers, to make sure you subscribe to the channel, right? Don't forget to like, share, and subscribe. Tell your friends, okay? So, right, so solve a pair of simultaneous equations. Now we have a pair of equations on the board that we want to solve simultaneously. And please make sure we can solve a linear and non-linear equation simultaneously. You are familiar with solving a pair of linear equations simultaneously using elimination or the substitution method. So we want to solve part A linear and non-linear. So this is your non-linear, which is a representation of a curve, and the linear is a line. Good? And what you want to do is to find the coordinates of the points of intersection. What will be the coordinates of that point? You're solving for 2 points of intersection. What will be the coordinates of that point? So you're supposed to get 2 sets of coordinates as your end result. So when you solve simultaneously, linear and non-linear, that is what we're supposed to get, right? But to solve it, we are using 2 things. We're using the method of using substitution method. So using the substitution method, and you also must solve. This must occur. You must solve a quadratic equation. So to solve simultaneously a linear and non-linear equation, you must use the method of substitution. You must solve a quadratic equation. Alright? So let's solve A. We have a pair of equations. Y is equal to 4 minus 2x. And y is equal to 2x squared minus 3x plus 1. Alright? Now, first thing is to label your 2 equations. 1, 2. And now let's implement the substitution method. Now, the linear, which is a less complex, is equation 1. Y equal to 4 minus 2x. The non-linear is equation 2. The more complex, right? So this is linear, this is quadratic. So what we're going to do is substitute the linear into the non-linear. So in equation 1 for the linear, y is already the subject, which is good. Y is equal to 4 minus 2x. So all you're going to do is substitute equation 1 into equation 2. So where you see y in equation 2, you're going to replace it with that 4 minus 2x. So that's what you're going to do first. Substitution method you're carrying out here first. So you are going to substitute equation 1, which is your linear, the less complex of the 2, into equation 2, which is the non-linear. So when I substitute equation 1 into equation 2, where I see y in equation 2, I'm going to replace it with 4 minus 2x is equal to 2x squared minus 3x plus 1. Good? And this equation we have here is a quadratic equation. And I hope we know what a quadratic equation and we can solve one. The quadratic equation is always recognized when you have variables squared makes it quadratic. This is an equation, there's an equal sign. So variables squared makes it quadratic. Equal sign makes it a quadratic equation, but the entire expression must be made equal to 0. So This here is a quadratic equation, but we have to make sure it's in the form of a quadratic equation. So, to do so, the final form of the quadratic equation is to take all we have on the left. We can take on the left, we can take on the right, doesn't matter. Take all you have on the left, let's put it on the right, put it equal to 0. So this will be, I'm moving negative 2x and I'm moving positive 4. Negative 2x will come across, this is 2x squared minus 3x plus 1. Negative 2x will come across as positive 2x. Positive 4 will come across to the right as negative 4. Of course, it's equal to 0 when I remove all from the left to the right. So we're going to get 0 is equal to 2x squared. Let me simplify. Negative 3x plus 2x will give me negative 1x or negative x. And plus 4 subtract 1 will give me negative 3. Plus 1 subtract 4, yes, will give me negative 3. So what I have here now is a quadratic equation. I have it in the form of a quadratic equation. Expression made equal to 0. Quadratic expression equal to 0. Now, students like to work with the quadratic expression on the left and the 0 on the right. If you want to do that at this point, no problem. So if you want to just switch them around, you can write 2x squared minus x minus 3 is equal to 0. No problem in doing that. Okay? So what we want to do now is solve that quadratic equation. We want to solve that quadratic equation. So this is testing your knowledge now of solving a quadratic equation. So carry on the method of substitution, create the quadratic equation, and now let's solve it. Okay? To get two values of x. Alright? So let's go solve to get two values of x. So in solving, what we're going to do? This is, I'm going to rewrite the quadratic equation here. 2x squared minus x minus 3 is equal to 0. So to solve a quadratic equation, you can either use the method of factorization, and you have to know how to factorize because you know factorization will come in the first or early part of the paper, normally question 2. So we'll use the factorization method, or you can use the method of the formula. This method, x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. You can also use that method to solve this quadratic equation. So it's up to you. I will go with factorization, alright? To make sure you can factorize. So to factorize this quadratic expression, what do we do? This is of the form ax squared plus bx plus c. So the first thing you do, you multiply a by c. So a in this case will be 2, c is negative 3. So I'm multiplying 2 by negative 3. 2 by negative 3 will give me negative 6. Good? But then I want 2 factors of negative 6, 2 factors of that negative 6 there. When multiplied will give me negative 6, but when added or subtracted can help me to get this negative x at the middle here. So I want 2 factors of negative 6. When I multiply it, it gives me negative 6. But when added or subtracted, it can give me negative 1x. What 2 factors of negative 6 I can think of? I can think of negative 3 by positive 2. Negative 3 by positive 2 gives me negative 6. But look at what also happens. Negative 3 attach x to it, and plus 2 attach x to it. Negative 3x plus 2x gives me negative 1x or negative x. So I've achieved my middle term. And once I've achieved my middle term, I am going to rewrite my quadratic expression 2x squared minus x minus 3 as this. 2x squared, I'm replacing negative x with negative 3x plus 2x. I'm maintaining my constant negative 3 is equal to 0. And what I'm going to do now is further factorize this by using a method of grouping. Alright? So I'm going to use a method of grouping to help me to factorize that. Oh, I do have to, oh, sorry. Oh, no. So someone asked the question. So therefore, let's further factorize this. So, to further factorize using the method of grouping, so I divide it into two pairs. Let me factorize this first pair. So to factorize the first pair, x is common to my first pair, so I take out x as my common factor. I'm going to divide x into 2x squared to give me 2x. I'm going to divide x into negative 3x to give me negative 3. Close brackets, that's me factorizing my first pair. Let me factorize my second pair. Always remember, when you're factorizing your second pair, using this method of grouping, the sign controlling the first term of the second pair, you write that first, and then you want to identify what else is common. Nothing else is common there, but what is understood after this positive sign is 1. So positive 1 is your highest common factor. So I divide positive 1 into positive 2x to give me 2x. I divide positive 1 into negative 3 to give me negative 3. Close brackets is equal to 0. And what I observe now, you know when you're doing this thing right, when you have the same expression in brackets. You see 2x minus 3, 2x minus 3, you have the same thing in brackets. So you know you're on the right track when you're factorizing using the method of grouping. So to further factorize, this is what you're going to do. You're going to take out what is common, which is the 2x minus 3. That is common. Easy approach now to get the two sets of factors as your end result. So because 2x minus 3 is common, you take it out as a factor, and what remains, which is this x and plus 1, I'm simply going to place in another bracket. So I take out my 2x minus 3, which is common, and my x plus 1, I simply put in the other bracket, is equal to 0. So this is me factorizing this quadratic expression. And now let me work towards getting two values of x. So to get two values of x, I'm going to use some keywords. Either 2x minus 3 is equal to 0, 2x is equal to negative 3 comes across to the right as positive 3, and to get x by itself, I divide both sides by 2. So x is equal to 3 over 2, that's one value of x. What's the other value of x? This is where I'm going to introduce my other keyword, or. X plus 1 is equal to 0. And therefore x is equal to negative 1. So I found my two values of x. But every value of x has a corresponding value of y. Remember, you want 2 points of intersection, x and y coordinates. So after I found my two values of x, by using this method of substitution, getting a quadratic equation, solving the quadratic equation to get two values of x, let me now go get my two values of y. Right? So every value of x will have a corresponding value of y. So let's get it. This is what we're going to do. And very straightforward, we're going to substitute I'll start off with x equal to 3 over 2 into equation 1. Always put it back into the linear. Into equation 1 to help me to find the y coordinate. So I'm going to get y is equal to 4 minus 2x. That is equation 1. And where I see x there, I'm going to replace it with 3 over 2. So y is equal to 4 minus 2, I'm replacing x with 3 over 2 in brackets. This becomes y is equal to 4 For negative 2 by 3 over 2 will give me negative 3, and therefore y is equal to 1. So my first point of intersection of the linear and non-linear, the line and the curve, the first point of intersection will be x 3 over 2 and y1. That's the coordinates, first set of coordinates I got. Let me get my second set of coordinates. I'm now going to substitute x equal to negative 1 into my linear, which is equation 1. So I'm going to substitute x equal to negative 1 into equation 1. So let me substitute it into equation 1. I'm going to get y is equal to 4 minus 2. I'm replacing x with negative 1. So I put negative 1 in brackets. So y is equal to 4. Negative 2 by negative 1 is positive 2. Y is equal to 6. So my second point of intersection, the coordinates will be negative 1, 6. So the 2 points of intersection that you're looking for at the end of your question are this and this. That's the objective. This is solving simultaneously a linear and non-linear equation. Please make sure you know this. Alright? They like to bring it from time to time, but it goes for a lot of marks. Alright? And you normally see it with questions where quadratics, where that is involved. Alright? So, you have that question. So I'm going to erase and let's move on to the next, which is completion of squares. Let's make sure we can complete the square. So I'm going to erase. So this question will be the last question because I have to close off at 11, right? So we do this question as the last. So part B, let's look at part B, C, and D. Good? So part B. Now we are asked to express 2x squared minus 3x plus 1 in the form a into x plus h all squared plus k, where a, h, and k are real numbers. So please look out for completion of squares. Okay? So we are going to take this quadratic expression, 2x squared minus 3x plus 1, and we want to put it in this form. The form is a into x plus h all squared plus k. Alright? Now there are different methods you can use to convert it into that form, but you know, I'll just use the simplest method. I consider it to be a simple method, where there's a formula for h and there's a formula for k. A is always a number in front of x squared, so you can find a off the bat. Alright? But there's a formula for h, a formula for k. Make sure you know that formula for h, make sure you know that formula for k, and when you get those values, you just substitute them into that form, which I'm going to show you. So you know, to start off, always identify what is a. This is ax squared plus bx plus c. Right? A will be 2, B will be negative 3, and C will be 1. So you start first by writing or stating what is A, B, and C. Already we know what is A. We know A is 2. So we know we're going to replace this A here with 2. So to find H, we're going to use a formula to find H. That formula is B all over 2A. We should know that formula to find H. It is B all over 2A. B in this case is negative 3 over 2 times A is 2, so I put 2 in brackets. So we're going to get to negative 3 over 4. So that will be H. So I'm going to replace this H here with negative 3 over 4. And K can be found by using the formula. You have to make sure you know the formula. The formula it is, if you're using this method, it's 4AC minus B squared all over 4A. So that's a formula we're going to use to find K. 4AC minus B squared all over 4A. So I'm going to replace A with 2, so I'm going to put 2 in brackets. I'm going to replace C with 1, so I put 1 in brackets. Subtract, I'm going to replace B with negative 3, so I place negative 3 in brackets all squared all over 4 times A. I'm replacing A with 2 in brackets. So let's simplify. Let's see what we're going to get as K. So 4 by 2 is 8. 8 by 1 is 8. Subtract, please don't say minus by minus is a plus and then write 3 squared, which is 9. No. You hold the subtraction sign. You square negative 3 first. Negative 3 by negative 3 is positive 9 all over 8. So 8 minus 9 will give us what? Negative 1 all over 8. And that there is equal to K. So K is equal to negative 1 all over 8. So we have found A, we know what is A. We have found H, we have found K, and therefore 2x squared minus 3x plus 1 in this form now will be written as, I'm replacing A with 2, open brackets, I leave x as is. I'm replacing H with negative 3 over 4. So if you put the plus sign and the negative 3 over 4, note a plus by a minus is a minus. So you can simply write negative 3 over 4 in bracket squared plus K. K is negative 1/8. If you wrote plus negative 1/8, note a plus by a minus is a minus, you can just simply write negative 1/8. So that there is expressing 2x squared minus 3x plus 1 in the form a into x plus h all squared plus k. And this is known as the method of completion of squares. Alright? So that is part B. So please make sure you know how to convert the quadratic expression into that form. And this is one method you can use. Alright? Now let's look at part C. Using your answer from B above or otherwise, and they love to ask this part after they ask you to complete the square. They always ask this part, right? Calculate the minimum value and the value of x for which the minimum occurs. You want the minimum value and the value of x for which the minimum occurs. Alright? So, what is the minimum value? Good? Now we need to understand that this here is a quadratic expression. A quadratic expression can also be represented as a quadratic function. You can represent it as so you can part C, y is equal to 2x squared minus 3x plus 1. Now that's a quadratic function. A quadratic function is always in the shape of a parabola. Good? Now that parabola can be a parabola that's concave up, or it can be a parabola that is concave down. It is concave up when the number in front of x squared, which is 2, is positive. It is concave down when the number in front of x squared is negative. So if you have to sketch this from, well, if you have to represent and ask us a sketch, but if you have to show a sketch of that function, note the shape of the curve will be concave up. So looking at this. Good? Now, what is the minimum value? Now, every parabola has what you call a turning point. Every parabola must turn at some point. Whether it's a curve concave up or concave down, it must turn at some point. Now, that turning point will have two coordinates. You have your x coordinate, which has a name. We call this the equation of axis of symmetry, because this line will cut the parabola in half, right? So it is known as your equation of axis of symmetry. And the y coordinate of that turning point will be called the minimum value, which is what I want us to find here. The minimum value. So we want to understand, when you talk about minimum value, what is the minimum value? The minimum value is the least value, right, on your curve, but it is also the y coordinate of the turning point, right? So it is the y coordinate of your turning point. And when they ask us for the value of x for which the minimum occurs, the value of x for which the minimum occurs is the x coordinate of the turning point. Yeah? So both minimum value and the value of x for which the minimum occurs can be obtained from this. This x coordinate of the turning point, y coordinate of the turning point can be obtained from your completion of squares format. Yeah? And how are we going to get it? Look how simple. I just hide that there. So just keep in mind, when you complete the square, you get to this form: a into x plus h whole squared plus k. When you get it in that form, just remember that the minimum or maximum value, in this case I asked us for the minimum value, right, in that question. Remember, the minimum, it can be minimum or maximum value depending on the shape of the curve. If it's concave down, you'll have a maximum turning point, hence maximum value, which will be the y coordinate of that point. This is a minimum turning point, hence this is a minimum value. Good? The minimum or maximum value is always k when you complete the square. Alright? So the minimum or maximum value, which is the y coordinate of the turning point, is always k. So one thing to remember. So the y coordinate of the turning point, or the minimum or maximum value, is k. And what is the value of x for which the minimum occurs, or otherwise called the equation of axis of symmetry? So the value of x for which the minimum or maximum occur, minimum or maximum value occur, that will be what? So the value of x at which the minimum or maximum value occur, the x coordinate of the turning point, that is always negative h. See the h I'm inside here? You're going to put a negative sign in front of it. So both the minimum value and the value of x at which the minimum occur, so we deal with minimum value here, right? And the maximum value. Minimum value in this case, right? Both can be achieved from this. So let's get the minimum value, which is part 1 of C. The minimum value will be, and let's take off, let me just write it here, write it over. The minimum value will be negative 1/8. Y is equal to negative 1/8. That's the minimum value. Good? Y is equal to negative 1/8. It is the y coordinate of the turning point. And 2, the value of x at which the minimum value occurs, which is the x coordinate of the turning point, otherwise called the equation of axis of symmetry. So the value of x for which the minimum occurs, that will be negative h. So all you're going to do is put a negative sign in front of what you want h to be. H is what? Negative 3/4. We worked that out previously, right? So you're going to put a negative sign in front of negative 3/4. And that becomes a minus by a minus is a plus. So you get positive 3/4. So the value of x is positive 3/4, which is the x coordinate of the turning point. So you call it the equation of axis of symmetry, or they say the value of x of which the minimum, in this case minimum, occur. Alright? So these two pieces of information are always asked anytime you are asked to complete the square. Good? They will ask you to find those two. So make sure you know what it is. Alright, so let's get the last part of this question. So I'm removing this. So looking at the last part of this question, what I'll do, I will keep these two pieces of information. We try to record that because that will come into play with the last part of the question. Alright, so we know we got the minimum value to be y is equal to negative 1/8, and we know the value of x for which the minimum occurred, that will be 3/4, right? Right, let me take this off. Alright, so let's look at part D. Right, very important part D. Sketch the graph of y is equal to 2x squared minus 3x plus 1 clearly. So what is to sketch this function? See, they put the y in front of it now. So it's a function you want to sketch. A quadratic function. Yeah? So that's what I want to sketch, a quadratic function. So they want us to sketch a quadratic function. And when you're sketching a quadratic function, it's not taking graph paper and plotting points, and it's not like this one here. It's not like that. It's not like that, eh? That is drawing. You fill the table, you plot the points, and you get your curve. Alright? Sketching is different. Sketching is simply put in a simple sketch in your notebook, but on that sketch you must see some important points, some important pieces of information. Good? When you're sketching a function, what you want to see on your sketch is this. You just do this on your exam paper of a quadratic, and you have to sketch it. So you make sure you put your y-axis. This is what you're sketching in your notebook. X-axis. You know that the number in front of x squared is positive, so you know that your curve will be concave up. You want to make sure when you sketch, you see where the curve cuts the x-axis. Alright, so that's an x-intercept. So the curve must cut the x-axis, the x-intercept. The curve must also cut or meet the y-axis. So you have a y-intercept, and the curve must turn. So a turning point. Those are the key things you want to see. So you want to see 1. So when you're sketching, you want to see your x-intercepts, which are 1, 2, where it cuts the x-axis, known as your roots. You call them roots. You want to see 2, your y-intercept. That is when the curve cut on the y-axis, you call it the y-intercept. 3, you want the coordinates of the turning point where the curve turns. So coordinates of turning point. And the last thing you have to know the shape of the curve, right? So we put 4, shape of curve. So you want to know the shape of the curve. Alright? So when we're sketching, we want to see those key pieces of information on your sketch. And if you look, sketch the function clearly showing the coordinates of the minimum point. Right? That is what we got in part C here. So we have that information. The value of the y-intercept. And I'll tell you what is the y-intercept, right? And the values of x where the graph cuts the x-axis. I'll show you that also. Alright? How we get that. And then when we have all that information, we can comfortably sketch. Alright? So let us get that information and then we will sketch our function. So let's state what we have already. Now we have, let's change this marker. So good, let's change that marker. So what we have already, we have this. We have the coordinates of the turning point. We have that already. So what are the coordinates of the turning point? The coordinates of the turning point is what we got in this part of the question, right? Which is the minimum value and the value of x, which is the minimum occur. That's why I stated it here, wrote it here, right? So therefore the coordinates of the turning point will be, the x coordinate of the turning point is 3/4, So I'm writing them as coordinates now. We have them separated. But as coordinates, it's going to be 3/4 is the value of x, which is the minimum occur, the x coordinate of the turning point. And the y coordinate of the turning point will be -1/8. And what I would suggest you do, write it in terms of decimal numbers, so make it much easier when you have to, well, you don't have to, but if you have the places on the sketch, you'll have an idea as to where -1/8 will occur, right? So, we know 3/4 is 0.75, and you know -1/8, that's -0.125. So at least you can gauge where it will lie when you have to plug the points, right? As a decimal might be easier to gauge. So you know the coordinates of your turning point, you got that before in the part C of the question, alright? Let's see what else we have. We also have the y-intercept. So we know what's the y-intercept? The y-intercept is this. When you have a quadratic function, when you have y is equal to ax squared plus bx plus c, the y-intercept is always c in the quadratic function. So the y-intercept, it is always c in the quadratic function. Okay? So you have to sketch y is equal to 2x squared minus 3x plus 1. So you have to sketch this. You have to sketch y is equal to 2x squared minus 3x plus 1. That's a quadratic function we have to sketch. Yeah? So we know the y-intercept, which is c, will be equal to 1. So we know that's where the curve will cut the y-axis. It's going to cut the y-axis at 1. Okay? So you know C, you know the coordinates of the turning point. What we also need to get now, so we have this. We need to get the roots. That is the x-intercept. Okay? Of course, we know what's the shape of the curve too. You already know what the shape of the curve. The number in front of x squared is positive, so you know your curve is concave up. So the only thing we need to get will be the roots or the x-intercepts, and then we can sketch our function completely. Because the question asks us, the question want to see these things, coordinates of the minimum point, you have them there. The value of the y-intercept, you have it here. And the values of x where the graph cuts the x-axis. So you need to find that. So how are we going to find that? 3. So our x-intercepts or roots, we're going to get that by solving a quadratic equation. Alright, when you solve a quadratic equation, you're going to get two values of the unknown quantity. In this case, we're going to solve the quadratic equation by taking the quadratic expression. So you're going to let 2x squared minus 3x plus 1 be equal to 0. So you're going to put that quadratic expression equal to 0, and let's solve that quadratic equation so we can get our roots. Yeah? So let's go solve it and get the roots. And once we have all that we need, we can sketch in our notebook, in our exam booklet. So let's solve that quadratic equation again. Knowledge of factorization, use the formula method. It's up to you. So if I'm using factorization, I'll say 2 by 1 is 2. And I want 2 factors of 2. When multiplied will give me 2. But when added or subtracted can help me to get negative 3x. And 2 factors are positive 2 I'm going to use negative 2 times negative 1. Negative 2 by negative 1 gives me positive 2, but negative 2x, so attach x to it, and negative 1 attach x to it, negative 2x subtract 1x will give me negative 3x. My middle term achieved. And what I'm going to do now is rewrite the quadratic expression as 2x squared. Replace negative 3x with negative 2x, subtract 1x, plus 1 is equal to 0. So you move from 3 terms to 4 terms. And when you have 4 terms, you're going to use your method of grouping to factorize it, to further factorize it. So let's further factorize. I pair off. So you divide it into 2 pairs. Let's factorize the first pair. What is common to my first pair? Clearly 2 and x, pull out 2x. Divide 2x into 2x squared. 2 into 2 is 1, x into x squared is x. Divide 2x into negative 2x will give me, when I divide this 2x into negative 2x, I get negative 1. Close brackets. Let me factorize my second pair. The sign controlling the first term of the second pair, that negative sign I pull out. I look to see if anything is common between x and 1. Clearly nothing is common. But what is understood after my negative sign is 1. So I have my brackets. So negative 1 is the highest common factor there. Let me divide. Negative 1 into negative x gives me x. And negative 1 into positive 1 gives me negative 1. Close brackets is equal to 0. What we observe? We observe we have the same expression in brackets, so it means we are on the right track. So, to help us to get our final product of factors, all we're going to do is this. We're going to take out x minus 1, which is common. Yeah, that's common, so you take it out as a factor. And what remains, which is that 2x and subtract 1, you place it in the other bracket, equal to 0. Alright? So you have your 2 sets of factors equal to 0, and now you can get your 2 values of x. See the importance of understanding how to solve a quadratic equation to help you to find your roots or your x-intercepts. So let's get the 2 x-intercepts. Either x minus 1 is equal to 0, and therefore x is 1, or 2x minus 1 is equal to 0, negative 1 comes across as positive 1, x is a half, or 0.5. So you know your 2 roots are 1 and 0.5. And sometimes, you know what CXC does? They let you do this before in another part before, so you don't have to do all this. So you have all the information before, and all you have to do is just transfer it onto your sketch now. So let's sketch. We have all that we need. We have the roots. We have the y-intercept, c equal 1. We have the coordinates of the turning point, 3/4 minus 1/8. Because when we completed the square, just convert them into decimal numbers. And we know the curve is going to be shaped like this. Because the number in front of x squared in your function is positive. Good? So let's sketch now. Let's put it on the sketch. And we will have our proper sketch. So let's sketch it. So I'll have my y-axis, x-axis. I'm going to have the roots 0.5. This is a sketch, so 0. I'll put 0.5 here. I'll put 1 here, right? That's my roots. My y-intercept is 1. I'll put 1 here. So you're not doing anything accurate. It's just a sketch. You just want to see the information on it. And then you have 0.5 and negative 0.15, 0.75, sorry, and negative 0.15. That occurs halfway between 0.5 and 1. Yeah? So 0.75 is here. Alright? And negative 0.125. If this is negative 1, negative 0.125 might be somewhere around here. So therefore, this is the coordinates of your turning point. This is the equation of axis of symmetry. That's the line that will cut your graph in half. And this is the y coordinate of the turning point. So this is the turning point right there. The curve will turn right there. Okay? So this is your equation of axis of symmetry, or the value of x for which the minimum occurs, and this is your minimum value. And these are your roots. And this is your y-intercept. So let's sketch it now. So I'm going to draw this as a sketch. Passing through. Turning here. Come up there, back. And as a sketch. That's a sketch of your quadratic function y is equal to 2x squared minus 3x plus 1. That's a sketch of your function. Alright? Yeah? So this will bring us to the end of this session. Tomorrow, what I will do, I will do some statistics. So look at some stats questions. We look at some functions, and we'll look at 1 or 2 logical deduction questions. Alright? Tomorrow is Saturday. Let me see if I can squeeze in some coordinate geometry too. And then Sunday, we focus on topics from question 1 to 5. Alright? So things like your trigonometry, make sure we're comfortable with that. Factorization, simultaneous equations, all those geometry questions, measurement questions, dealing with area, perimeter, volume, dealing with those questions, construction, we see if we can get some construction done, consumer arithmetic. So we look at those questions on Sunday, right, before the examination. Okay, so we try to cover as much as possible before the exam. So we're going to end the live now. So have a good night. Don't forget to like, share, and subscribe. Tell everyone you know to come and join and be a part of this preparation for exams on Monday. Alright? So have a great night. See you all tomorrow. Take care, everyone.